So now we're going to focus on using an NPN bipolar junction transistor as a switch. So I have a switch here, but the switch is not turning the LED on or off. It's turning the transistor on or off. It is a signal. It's a weak signal compared to the load that the transistor is switching. So with the mechanical switch here open, there's no base to emitter current. You need base to emitter current for collector to emitter current. So there's not going to be any collector to emitter current. The load is going to be off. So now, what closing the switch does in this circuit is allow current to flow from base to emitter there. It's a very small amount of current, mostly due to the 10K resistor, but you also have a diode drop right there. But whatever current's flowing through here, the collector will allow many times the amount of current, more than 20 milliamps of current. So in this case, it'll be the load that sets the current through collector to emitter. So now, when you see an NPN bipolar junction transistor schematic symbol, it may not be circled though, and usually it's not named. Pins are not usually named. But in any case, we got collector up there, base over there, emitter over there, and you got to match that with the physical component you're using. Maybe there's a part number, but whether there is or not, use the part number that you got, 2N3904. We got emitter on the left, base in the middle, and collector on the right when you're looking at the front. If you're using a different transistor, it may have a different pin layout. This one has emitter on the left, collector in the middle, and base on the right. So here you can see collector on the low side, make sure the LED is right way, base is where the signal is, and emitter is where ground is connected. So on the breadboard, collector on top, low side, base in the middle, that is where our signal is, and emitter goes to ground. So now, bipolar junction transistors, this is the NPN version, have gain. What that means, for whatever amount of base to emitter current there is, it's going to allow many times that amount collector to emitter. The amount is gain. So if we have a gain of 100, 2N39.4 is over 100, but it's not set in stone. But it's pretty much always over 100. That means for 0.43 milliamps of current flowing through base to emitter, the transistor will let 43 milliamps of current flow through. The load, though, is lower than that, so it's going to be whatever the load is. Now, for that 43 milliamps current, we got 5 volts from the supply. Base to emitter is dropping about 0.7 volts. So we got about 4.7 volts across the 10K resistor. I did the math there, and that gives us 43 milliamps of current. You do the math in amps, though. And so you take that current times 100, second line down there, and that gives us 43 milliamps of current. It will let flow, but in this case, the load limits the current. So now, an important property when you're designing circuits with the NPN bipolar junction transistor is their maximum current. So the 2N3904 has a relatively low maximum current, 200 milliamps, but in this case we're lighting an LED, so it's much lower than that. We're using a 150 ohm resistor. When the transistor on, that'll keep it below 20 milliamps. If you got a load that is going to be switching, you're going to be switching more than 200 milliamps especially, but probably over 100 milliamps, you should use a different transistor that can handle more current. But in any case, the way that we got that 20 milliamps of current, when the transistor is on completely, it's basically a closed switch. It's almost like a piece of wire going to ground. Red LED drops 2 volts. We got 3 volts across a 150 ohm resistor, giving us 20 milliamps of current flowing through the circuit. That's the absolute max for LEDs. You should probably use a higher value and get less current than that. But I added that because it's the minimum right there. Use that or a higher value.